Hello, I am Jens Nickel from Elektor. This is the second day of the Embedded World Show 2022, and we start this morning at the booth of the measurement company Rigol. This is Mr. Adlung, he's sales manager. And Mr. Adlung, you have here a very special device. It's very fast, and maybe you can say some words.
Yes, exactly. This is our new high-end oscilloscope from Rigol Technologies. This is one part of the program Station Max. So we plan to provide several test devices from this program. And we have in this series two devices, one 3 GHz version and one 5 GHz version. This one contains on the platform UltraVision 3, which contains our self-developed ASIC chipsets from the name of Phoenix. And we have the possibilities to generate a sampling rate up to 20 gigasamples per second, bandwidth up to 5 gigahertz, memory depths up to 2 gigapoints. So a lot of data can be collected with the test device, and you can make very fast measurements because we have a very high trigger rate of 1 million waveforms per second. And additionally, we have implemented many applications for customers. For example, real-time eye measurement capabilities. We have implemented jitter capabilities. We have inserted our ultra-real technology for with real-time spectrum analysis capabilities. Compliance tests for USB and Ethernet, for example. Different decoding systems. So we try to make a really complete test device for our customer base.
Okay, up to now, Rigol is very famous for low cost and medium price oscilloscope. And now you also have a high-end oscilloscope. What are the applications for this oscilloscope? What are the targets?
So we have different applications we can offer. For example, such kind of applications like the real-time eye are for high-speed data analysis, for example. Or when the high-speed data analysis works together with a clock, then you need, for example, as well jitter capabilities and jitter analysis methods. We have a very good combination of time signals and frequency domain measurements, so all the bandwidth applications could be the case, not only the high-speed data transfer. So we have different kind of capabilities which can be measured, and also for automotive, for decoding stuff, for example, could be interesting. For EMC pre-compliance could be used with spectrum analysis capabilities. Such kinds of applications are interesting with this test device.
Do you think you get new clients with these special kind of oscilloscopes?
So yes, of course, new clients, but really, to be honest, during this exhibition, I learned a lot that the new clients already have mainly Rigol test devices. So with the smaller ones, or with the mid-range scopes, or with power supplies, spectrum analysis. So very often customers know us already. And this, of course, this helps because they know our high quality, they know our very good price performance we have, and this helps, of course.
And do you think you can convince clients who are already familiar with high-end oscilloscopes to switch to Rigol?
Yes, we think so, because I introduced the platform in the previous discussion here, and you can see such kind of parameter are really good parameters, and they are competitive on the market. And we also try to use the same principle what we used the last several years to bring our customer a very, very good price and performance capabilities. And we also decided to bring with different applications we inserted in such kind of oscilloscope to make it very interesting for customers. And the customer feedback since we launched this product is exactly like this, very positive.
Okay. You mentioned 5 gigahertz bandwidth and 20 giga samples per second. And what is the price range approximately for this?
So we're starting with 23,000 euro with the boxes.
Are there special services included? Or?
So we're providing for all of our customers, of course, a special service because we are located in Germany for our European customers. We have a very good application team here in Germany responsible for the European customers. And of course, we have a service department in case a repair would be required or customers require calibrations. And this we offering also for each test device a 3 years warranty, like for all other test devices. And this service is of course available in with the test device.
If you sample with 20 giga samples per second, then you get, of course, a lot of data. How can you get these data out of the oscilloscope to analyze it further?
This is a very good point. You have capabilities to connect the test device on different stages, for example with USB, Ethernet and so on. When we take a look at the Ethernet communication, then you can connect it and you can open web control. We have an enhanced web control capabilities. For example, you can make a full control over web control. You can do screenshots, videos, you can send Skippy commands and receive the feedback of the device. And everything can be done without installing any driver. And here we have also capabilities to transfer data from the device to the PC because you can use the test device as a FTP server. You open Explorer, put in the IP address, and then you open the memory of the device. You can, per drag and drop, bring the data from the device to the PC. Very simple, very fast.
This is the first device of the new Station Max series, and I think there's a very special component in there, ASIC.
Exactly. Yeah. So we developed in principle 3 kinds of ASICs. 2 are for the oscilloscopes. The other one is for our RF probe, which goes up to 7 gigahertz. And this one contains as well our self-developed ASIC chipset. In this probe, by the way, we have all the different heads for single-ended and differential connection, for soldering and for normal testing with tips. We have different tips which can be replaced. Also for the soldering, we have replacement cable here inside, and the customer can replace it. So this is designed for a very long lifetime. And the other 2 ASICs, as I told you before, are installed in the oscilloscope. The first ASIC is installed in each front end. Wait a second, I go a little bit back here with the display. And here at each analog front end, and it's responsible for the impedances 50 ohms, 1 mega ohm, for the overall voltage protection. It's quite fast. It's really realized via the ASIC. And the other chip is installed before the analog digital converter, and it's responsible for the low noise of signals and for a good amplitude before it goes to the analog digital converter, and for the speed for the analog digital converter.
And this, of course, you let produce this chip, this ASIC chip, so you are not affected in that case from the chip crisis.
So for this specific ASIC chipset, no. But of course we have other test devices, and we see also the influence. And the last 15, 18 months, and from our point of view, I have to say it very honestly, it's really a hard job and a lot of communication together with our production and our purchase department at Rigol to manage this case. But I have to say it also, to be honestly, our customers didn't feel it till end of December because we were able to deliver everything. And now, thanks to the very good internal communication and our corrective actions with it, we are able to deliver 95% of all of our product ranges to customers. So it's very limited products which cannot be delivered, and the rest is more or less on stock, and we can deliver immediately.
Okay. We said this is the first device of the Station Max series, so others will follow.
Yes, we have another test device here at the booth. We launch it next week, so I can show you. So, this is the next brand new version of the Station Max program. This is a multifunctional generator. I will also show a little bit close the screen. We have 4 different channels. So channel 1, 2, 3 and 4. You see we have 3 outputs for each channel. 2 DC outputs, but DC doesn't mean you have no bandwidth. Of course you have bandwidth. And you have 1 AC output. The AC output can be used, for example, for carrier signal up to 5 gigahertz, and with IQ modulation, for example. and the DC outputs can be used, for example, for differential signals, and of course for more voltage than on the signals than the AC output. And here we have the capabilities that you can bring out IQ bandwidth up to 1.5 gigahertz. So a very, very big bandwidth. The maximum output frequency is 5 gigahertz. It's DC to 5 gigahertz. It has arbitrary functionalities, so you can bring out ARP signals. You can also bring out sine, square, whatever. We have here also the possibilities, for example, to create sequences. For example, you can use a sine wave, a square wave, an ARP wave, an IQ wave together in one sequence and put it out at one output. Or as you can see here, you can also put out here an IQ modulation. Here I put it out here 128 QAM as an example, and you can decide what kind of code types. For example, I selected here PRBS, which is commonly used for testing such test devices. You have also several kinds of PRBS you can add, and so you have full flexibility then with the test device. Additionally, we have also the possibility to bring out marker capabilities for each channel to markers. That means in sequences you can define special points where the device decides to trigger out on the marker output. And so you can also trigger other test devices which is connected to this box. Or you have also digital jump insert on the rear side where you can bring in a pattern. And with this algorithms according to your need, and then you can make jump signals like a Bluetooth signal, which is a jump signal. And such kind of capabilities are possible with such kind of test device. And we also have the possibility to make a very, very good synchronization of each channel in picoseconds area. And because this test device is also designed for quantum computing, to stimulate the quantums then in this case. So we have also the capability, if it's required, to extend the boxes, and we can combine different boxes up to 220 channels.
Okay, my last question is maybe a little bit dumb. Why do we need these big housings for these kind of devices? Is it because of heat probabilities, or do we want to decouple the components? It's a little bit distance, or what is the reason?
So this is related to the Station Max program, because we have here in this case different functionalities inside. This is the generator part at this box. This is the oscilloscope part of this box. So a lot of technology is inside. Therefore, we have providing a lot of functionalities. And the big screen is also one of the reasons. And the second screen to control the test device here with the shortcuts. And of course, we also plan to provide more test devices in the Station Max program. For these kind of test devices, we need the place. And this is related to this kind of program.
So there are still extension slots which can be filled?
Exactly.
Okay. Thank you very much.
You're welcome.
And success for the show.
Thank you very much.